Hello, welcome to part 3 of finding critical regions for binomial hypothesis tests. This is the final video focused on just finding critical regions, but be aware there's many more aspects to hypothesis tests than just this. There's other videos on this channel which are going to be focused on the full process as a whole, including how to set it up at the beginning, how to interpret your answer at the end, all that stuff. So if you want to fully answer a hypothesis test question, please do watch those videos as well. Anyway, in this part 3 video, we're going to be looking at some extra details that we didn't mention in the other 2 videos, sort of more special things to watch out for in the wording and how that affects certain calculations you do, things like that. But therefore, it's worth pointing out, I'm going to be assuming that you have already watched part 1 and part 2, or at the very least studied all of that stuff, because I'm going to be using those skills in this video kind of as a given already. Right then, okay, let's get on it. So the thing we're going to look at first of all is something you need to watch out for in the wording, because until now, the significance level is something we've been treating as a threshold that you need to get as close as possible to without going over when calculating your probabilities. That's not the probability of the binomial distribution, that's the probability you're getting out from doing calculations. And so that's what our default assumption was if the wording didn't mention anything more than just going, oh, this is the significance level, and you just therefore could get on with it. However, if there is wording along the lines of find the critical region, the probability in the tail should be as close to 2.5% as possible, that does change our approach, because it's slightly suspicious that they're mentioning that the probability should be as close to 2.5%. 2.5%, nothing weird about that. The significance level could be whatever you want, but it's weird that they're mentioning that it should be as close to 2.5% as possible, because in some ways, as I already said, that's our default assumption. So then, therefore, the suspicious part is the fact they're mentioning that, but then not mentioning the usual restriction of the fact you're not allowed to go over 2.5%. So therefore, if this is the wording they give you, that means that we are allowed to go over the significance level if doing so does result in a probability that's closer to the significance level than the last probability that was still below the significance level. So we're just, in this sort of question, trying to get as close to the threshold as possible, regardless if that involves a probability that's below the significance level or one that is above the significance level. Whichever one is closest is the one we pick. So let's look at an example. So the example is h0 is p equals 0.7. We've got h1, we've got our distribution, and then we've got the wording. Find the critical region. The probability in each tail should be as close to 4% as possible. Now, the first thing worth pointing out is this is a two-tailed test. But interesting, we've got to be really careful when reading about the significance level, because normally what we do with two-tailed tests is we take the significance level and we halve it for each tail. But if you read the wording very carefully, you'll realize that in this wording, they are already implying that they've done that for you, because they're saying the probability in each tail should be as close to 4% as possible. So that means we don't need to do 4% divided by 2 this time, because they have already done that dividing. They're talking about each individual tail, the significance level being as close to 4% as possible. But as mentioned before, as close to 4% as possible, so that means we are trying to get as close to it as possible, but that does mean we are allowed to go over 4% if that does result in one that's closer to 4%. Okay, let's start doing the calculations. So, ultimately, these are the calculations, 4 calculations you do. Ultimately, this wording doesn't actually change which calculations you'll do. It's only how you'll interpret them. So you're still going to do, try and get as close to the threshold as possible without going over. And then that's the first one you'll write down. And then you'll also write down the first one that goes over the threshold. And then, as it's a two-tailed test, you do that for both the lower tail and the upper tail test. And of course, you can see that less than or equal to calculations are for the lower tail, the greater or equal to calculations are for the upper tail. Nice. So those are the 4 probabilities that match those conditions. The last one that's below the threshold and the first one that's above the threshold. Now, interestingly, if this was one of the previous questions we've been dealing with, we would have automatically ended up picking probability of x is less than or equal to 9, because the probability of that is the closest we can get to 4% without going over it, because x is less than or equal to 10. You can see it's over 4%. And then on the upper tail, x is greater or equal to 18, because that's the last one that's still below 4%, because greater or equal to 17 is 10%. That was what we did before, but that's not going to be the case anymore. This time we're going to be looking at both of these probabilities for each tail and deciding which of the 2 probabilities is closer to 4%. So for the lower tail, looking at these 2 probabilities, that means actually when we look at it, we realize that the 0.0480, despite being bigger than 4%, is closer to 4% than 0.0171 is. Now, this is one where I thought was quite easy just to be able to look at it and just instantly know which one's closer. Sometimes if it's a bit more difficult to see, you might want to take away both of these probabilities from your threshold, in this case 4%, so then have to see the difference, so then it's a bit easier to see which one's further away. This one I haven't bothered to do that, and you don't need to do it for the method, it's worth pointing out. You're not expected to show yourself doing that, but it's something you could do if you wanted to, if it helps you out. Then for the upper tail, looking at the 2 of them, well, for this one, we are still going to pick the one that is below the threshold, because the one that's above the threshold is further away from 4%. 3.55% is less than 1% away from 4%. Obviously, the other one's 10%. That's over 6% away, so definitely not the one that's nearer. So therefore we've got the 2 that we've chosen, and therefore that informs that the critical region we're going to pick in this case is x is less than or equal to 10 union with x is greater or equal to 18. So there you go, that's how you find the critical region if it's got this wording where they mention it should be as close as possible, but suspiciously they don't mention that you can't go over the threshold, so therefore they're taking that restriction away. Okay, that's not the only thing we're going to be looking at in this video though, because there's often, you might notice with the example I've just said, part A. Another thing you can sometimes be asked as part of critical regions for binomial hypothesis tests is to do with finding an actual significance level. But what does that mean? Surely we were given the significance level already. Well, the thing to understand is that the significance level is the probability that a test statistic is in the critical region. In other words, it's basically meant to be the total probability that the critical region takes up. The problem is, with binomial hypothesis testing, because we can only make the x values be whole numbers because they're measuring successes, it's a discrete random variable. That causes a problem because it means you're very, very, very unlikely to end up getting a probability when calculating the critical region that ends up being exactly equal to the threshold of the significance level. So, therefore, the significance level of the test that you end up actually doing ends up not actually being the significance level given in the question. It ends up being the size of probability that you got when you did do the calculations to decide your critical region. So let's look at an example. Again, same situation we had before, so it's the same H1, the same distribution, and therefore we'd already done the same calculations that we'd done before to decide our critical region. Those were, we had already done decide the lower tail part by realizing that probability of x is less than or equal to 10, and that ended up being 0.480. However, it's worth pointing out that was a rounded value when I was writing that down to 4 decimal places, and because we're going to be doing further extra steps to these numbers, it's good to use an unrounded value in your calculation. So that was it before, that was the value of it before I had done the rounding. And then for the upper tail, we ended up calculating probability of x is greater or equal to 18. That's the one that ended up deciding the upper tail. And again, though, that was rounded. So before it was rounded, that is what the probability looked like. Now, therefore, the actual significance level is the probabilities we can see written there. As it's a two-tailed test, it's going to be these two probabilities combined. So therefore, the actual significance level of this hypothesis test is those two probabilities added together. And that will get us 0.0834. So that means the actual significance level of this hypothesis test was 8.34% to 3 significant figures. There you go. So it is just a simple case for the actual significance level of just looking at the probability you calculated and just saying that's basically the actual significance level. And the only added step, if it's a two-tail test, add the two probabilities for the two tails together to get the actual significance level. There you go. That is that for finding critical regions. That's all our parts for that. It's worth pointing out critical regions is not the only method you need to know as part of doing binomial hypothesis tests. So do watch out that there is a second method that you also need to know, and I will have a video on that as well. So see you in a future video.